Today's lesson is the first of two looking at section 7.1 called stoichiometry. Stoichiometry is the relationship between quantities in chemical reactions. Historically, it used to be referring specifically to masses, but now it refers to basically any chemical quantity that we're looking at. It can be used to calculate, in other words, predict, the amount, frequently masses, needed to cause or we will produce during chemical reaction. So we can look at a product, figure out how much of a reactant we need. We can look at a reactant, figure out how much product we'll make. We can look at a reactant and see how much of the other reactant we need. Any combination of these are possible. It's of course going to require a balanced chemical reaction. So obviously the symbols and the reactions must be correct in order for this process to work properly. Moving on in 3, 2, 1. We're not going to copy this slide, but I'm going to work you through the process. Cooking is a synthesis reaction. 2 bread, 5 meat, 3 cheese makes 1 sandwich. If we did the extra step of toasting it and pressing it, we'd have a panini. The ratios between the coefficients let us solve quantities, and most of us do this in our head so fast we don't even think about it. If I have 4 bread, I can make 2 bread, 1 sandwich, 4 bread. We're going to get 2 sandwiches. Awesome. How do we actually get that? What we really did without thinking about it was we drew a line. We said from the reaction there 2 bread makes 1 sandwich. And then we canceled and went 4 times 1 divided by 2 equals 2. Okay, and that's how we got the 2 that we put there. To make 4 sandwiches, I need how much meat? Well, the numbers are starting to get a little bit bigger. 4 sandwiches, and we're going to say, all right, so we have 1 sandwich and 5 meat. The sandwiches cancel, and we get 4 times 5 equals 20. We're going to need 20 meat. All right, we're going to go on to the next slide now. All right, we're back to copying. We're looking at something called the mole ratio. The mole ratio is the ratio between coefficients in a balanced chemical equation. The ratio applies to molecules, forming units, moles of a substance. So it can be applied to all of these. Your textbook tends to break up all these and treat them as separate concepts, but they're all really the same. While they will often express it as a ratio like 2 to 1, it's more useful to express it as a fraction, and when we get there I'll show you how, but you saw on the previous slide that we were writing everything in fractions, not ratios like this. Initially, we trust that we have all the other materials. So when we were talking about making sandwiches, we just trusted that we had lots of the other materials, and we were worried about, okay, do we have enough of such and such? Moving on to the last slide now. We're given the reaction of a chemical called ethane and oxygen making carbon dioxide and water. This is a complete combustion reaction. If I've got 10 molecules of that C2H6, how many molecules of water can be made? So molecules of water, we start off with the given information. We have, and I'm going to narrow that point a little bit so it's fitting in a little better, 10 molecules C2H6 times, then we're going to use the ratio of 2 of the C2H6, and because we're looking for water, I go to the reaction and find that there are 6 H2O, and then I can say that that cancels, and then this is going to simplify to 10 times 6 divided by 2, We put that into our calculator. 10 times 6 is 60, divided by 2 is 30 molecules of H2O. Next example from the same question. If there are 15 moles of CO2, so not molecules this time, entire moles, how many moles of oxygen are needed? So now we're looking at N, the number of moles. The given information is we have 15 moles CO2. We're going to multiply by that mole ratio, written as a fraction. From the equation, the CO2 has a coefficient of 4. We want to know about the O2. Its coefficient is a 7. We're going to cancel the CO2, CO2, and so it's going to be 15 times 7 divided by 4. Your calculator is going to give you 26.25 moles of O2, which we are going to round because we have to have two significant figures. 26 moles of O2. That's the piece for tonight's lesson. Thanks for watching.